right, in this video, we're going to talk about graphing standard angles in radians. So if you've seen my video on how to graph standard angles within degrees, it's extremely similar. The first thing that we need to know is we need to know what our quadrantal angles are in terms of radians. So I know that this is going to be 0 and it's going to be 2 pi. That means all the way around our circle, we get 2 pi. If you wonder where that 2 pi came from, I did a video on what is a radian. Go check that out. I explain in there where the 2 pi comes from, but simply 2 pi is the distance around any circle with a radius of 1. So half of 2 pi is obviously going to be pi, so halfway around the circle is just pi. In between 0 and pi, we get pi over 2, half of that, and then this is going to be 3 pi over 2. Now, one thing that I find to be very helpful with this is I start thinking of these fractions in terms of money, right? Everybody likes money. Well, if I'm given a fraction, a radian that I need to graph, I need to think about where does it fall in terms of 0, 1/2, 1, 1.5, and 2. Or you may have to go past it if we go all the way around the circle more, right? So just start thinking about these fractions as actual decimals, and I think it'll help you a little bit. So let's jump straight into the first example. This first example, they want us to graph 13 pi over 10. Now, again, I'm positive, so I know that I'm graphing this way. But 13 pi over 10, that's a little weird because we had 0, 2 pi, pi over 2, pi, and then 3 pi over 2, right? Well, if I start looking at this as 13 over 10, I know that's 1.3. And so I know that if this is 0, this is 1/2, and 1 in 1.5, I know that 1.3 is going to fall somewhere around right here. And again, we're just estimating. I draw my arrow to show that I have gone past pi, that I've gone positive, so we're going this way, we're going counterclockwise. And then we end by just saying 13 pi over 10. Okay? So that's our first example. Again, I'm thinking about it just in terms of money. 1.3, I'm looking at the fraction without the pi, and then I'm finding that estimate about where it would be. So we'll look at another one. Here they want us to graph negative 3 pi over 4. Well, the negative numbers are going to be done the exact same way as they were with degrees. This is going to be 0 and negative 2 pi. This is negative pi over 2. This is negative pi, negative 3 pi over 2. So again, I'm still thinking about this in terms of money, right? 3/4 I know is 0.75. So if I start thinking about this as 0.75 pi, we have 0, we have 1/2, we have 1. So negative 0.75 pi is going to fall right here. Tell me which direction we went. Write in our negative 3 pi over 4, and that's it. So again, when we graph the negatives, the negative numbers are going to go clockwise around our circle, and we're going to wind up down there in quadrant 3. Think about it in terms of money. Figure out where we're going based on our quadrantal angles, and then we place our estimate in that quadrant. Last example, we have 13 pi over 6. Well, again, I'm thinking about it in terms of money. 13 over 6 is approximately 2 point something. I'm going to say 2.2, 2.1, somewhere around in there. But I know 0 and 2 pi is there, pi over 2, pi, 3 pi over 2, and this is 2 pi. Well, if I had to go again, this is going to be 5 pi over 2, all right? Which that number, that fraction here, represents 2.5, and this is 2. And I know that my angle is going to be in between those two right there. So if we have to estimate, draw my angle about right there. If you're off a little bit, that's okay. But I have to state that we went positive, so we're going counterclockwise, and I went past that distance of 2 pi. So I have 13 pi over 6. So again, these are done the exact same way that we did with the degrees. And so I hope that after watching this video, you feel a little bit more comfortable with graphing radians in standard position. Easiest way to me, and the way that I like to think through it, is just think about it in terms of a fraction. Think about it in terms of money. Where would that fall on our quadrants? So I hope this video helped. Be sure to check out the other ones discussing what a radian is, finding coterminal angles within radians. And yeah, thanks again for checking out the video. See you guys next time.